Dear students, after completion of the two topics which are vectors and scalars, thereafter projectile motion, we are having the last topic in this chapter is uniform circular motion. Uniform circular motion, uniform circular motion, non-uniform circular motion. Okay, in which first uniform circular motion. What is meant by the uniform circular motion means, just to see the definition, if the object is moving along the circular path of radius with a constant speed, then the object is said to be in uniform circular motion. Now whether you are observing or not, this is nothing but one circular path. Right now this is nothing but one circular path of radius is nothing but how much? Is nothing but r radius. Now this is origin of the circular path, center of the circular path. Okay, now this is the radius of the circular path. Is it? Now any one object, the object which you are selecting, any one object is moving along the circular path with a constant speed, then the object is said to be in uniform circular motion. Okay, uniform circular motion. In uniform circular motion, what is constant? Speed is constant. Is it? Suppose if you take the velocity, what is the velocity of the object in uniform circular motion means? Velocity is nothing but what is that? Speed plus direction. Speed plus direction. Okay, throughout the speed, throughout the motion. Okay, speed is nothing but it is a constant. Speed is constant. Speed is constant. Then what about the direction? Direction is keep on changing. That means velocity direction in uniform circular motion is keep on changing. Sir, at this point, what is the direction of velocity? At this point, what is the direction of velocity? At this point, at this point, at this point, at this point. Any one of the point if you consider. At that point, what is the direction of the velocity of the object in uniform circular motion means? Along the tangent to circular path at that point. Now this is nothing but velocity vector. What is the velocity of object at a point A means at a point A? Velocity of the direction of the velocity is along the tangent to the circular path at that point. That means tangent means the line which is that means tangent means the line which is touched to the circular path at that point. Sir, here what is the direction of velocity? Here the direction of velocity means along the tangent to the circular path at this point. Okay, velocity. See here, if you see at this point, velocity direction is like this is there. At this point, velocity direction is like this. That means direction change. Is it? Now, at this point, what is the direction of velocity vector? Along the tangent to the circular path. Here, along the tangent. Here, along the tangent to the circular path. That means, okay, here, throughout the motion of the object, speed of the object is constant, but direction is not constant. Direction is not constant means, okay, direction, what happened to direction? Direction is changing. If the direction is changing continuously, okay, then velocity also change. Here, keep on, direction is changing, okay, speed is not changing. So, if the direction, velocity must be changed means, okay, among these two, any one change, otherwise both change. Okay, right here, direction changing means velocity also changing. So, in a uniform circular motion, velocity is keep on changing along the circular path of an object. That means when the object is moving along the circular path, the object is moving along the circular path. In that case, velocity is keep on changing. If velocity is changing means, okay, the motion of the object along the circular path is nothing but what type of motion? Accelerated motion, which is a accelerated motion. They will ask one more question. Uniform circular motion is dash. Option A, accelerated motion. Option B, non-accelerated motion. Option C, uniform motion. Option D, none of these. So accelerated motion. That means when the object is moving along the circular path, okay, its velocity is keep on changing. If velocity is keep on changing means then the object is said to be moving with accelerated motion. So uniform circular motion is accelerated motion. That means in uniform circular motion, object is having, okay, acceleration. What is that acceleration? Let me find out later onwards. Right, next, see, let me see here few definitions we have to study, okay, about this one. First one is nothing but angular displacement. Angular displacement is denoted by which letter? Is nothing but theta. So let me see here, first of all, angular displacement. See, what is the angular displacement? You just to see like this. So this is the circular path of radius r, and this one is nothing but r is in O. Initially the object is at a point A. After some time the object has reached to point D. That means to reach to point B, when it is traveling from A to D. When it is traveling from A to D, okay, how much distance it is covering? That is nothing but this distance. Right, the angle, you see, this is A, radius of position A. This is the radius of position B. In between these two, if you measure the angle means this angle is said to be here angular displacement. Angular displacement is nothing but, okay, the angle subtended or made subtended by the object at the center of the circular path. At the center of the circular path is called here, is called angular displacement. Angular displacement. This angular displacement is denoted by which letter? It is denoted by a letter that is nothing but theta. Theta equal to angular displacement can be measured the length of the arc divided by radius. Length of the arc divided by radius. So length of the arc is nothing but, what is the length of the arc? This curved part is nothing but S. So divided by radius is nothing but r. Okay, next one, angular displacement unit can be measured in terms of radian. Measured in terms of radian. Okay, in simple form we can write radian is nothing but radian. Okay, angular displacement is nothing but the angle subtended by the object at the center. When the object is moved from one point to another point on the circular path, the angle subtended by the object at the center of the circular path, this angle is called here angular displacement. Okay, right. Now afterwards we may have here angular velocity. Angular velocity. Angular velocity is denoted by which letter? That letter is nothing but omega. Right. Now see here, after having angular acceleration, angular velocity. Velocity is nothing but the rate of change of displacement. Angular velocity means the rate of change of angular displacement. Velocity means rate of change of displacement. Angular velocity means rate of change of angular displacement. So angular velocity omega is equal to angular displacement by time. It is nothing but angular velocity. Right? Its unit is nothing but what we can write, radian per second. We can write radian per second. Next to angular acceleration. Velocity is nothing but acceleration is nothing but rate of change of velocity. So angular acceleration means rate of change of angular velocity is called angular acceleration. Angular acceleration is denoted by alpha. Angular velocity is denoted by omega. So angular acceleration is equal to angular velocity by time. We can write. Next, from this one we can write. From this one we can write. Just to see unit for this one is nothing but radian per second square. Right, next one, time period. Time period is denoted by a capital letter, that is nothing but we can write. Time period means period of time means the total time taken by the object to complete one revolution along the circular path is called here time period. Is it? Next one, frequency. Right. Frequency is denoted by F or nu. Okay, let me see. Frequency means the number of revolutions made by the object in 1 second. In 1 second, 1, 2, 3, 4, 5. How many number of revolutions are made? Some n number of revolutions are made. That means the number of revolutions which are made by the object in a time 1 second is called here frequency. Frequency is nothing but you write in your notebook the number of revolutions made by the object in 1 second. So frequency F equal to 1 divided by what we can write T we can write. Right? Its unit is nothing but hertz. Hertz is the unit for frequency. Now thereafter, let me have here the relation between linear velocity and angular velocity. Right? Now from the angular displacement, from the definition of angular displacement, we have theta equal to s divided by r. Now differentiate with respect to t on both sides. Right, then what we can write, d theta by dt is equal to 1 by r into ds by dt. d theta means change in angular displacement with respect to time is nothing but angular velocity is equal to r into 1 by r into we can write v. Now from this one v is equal to we can write r omega. Now v is nothing but linear velocity, r is nothing but radius of the circular path, omega is nothing but angular velocity. In vector form, how we can write means v bar is equal to r bar cross omega bar. You can write it. Now this is nothing but the relation between linear velocity and angular velocity. Next one, relation between acceleration and acceleration. Okay, let me have. Now we know that the relation between linear velocity and angular velocity like this. So this one also differentiate with respect to t time on both sides. Right, let me see here. dv by dt is equal to r into d omega by dt. Why? R is constant. Constant I have written outside of the derivative. Here also outside of the derivative. Right? Rate of change of velocity is called here acceleration. So r into angular velocity by time is nothing but angular acceleration. So this is the relation. In vector form, same relation how we can write means a bar is equal to R bar cross. Okay, you can write it right. Now this is about this one. Right, actually angular velocity means for a complete revolution, for one complete revolution, angular velocity is equal to angular displacement by time also, you can write. So we can write it like this also. Omega equal to 2 pi into 1 by t. 1 by t is nothing but how much? F. F also we can write. Okay, we just keep it in. Now these are the basic information about the uniform circular motion. Uniform circular motion means, suppose if the object is moving along the circular path with constant speed, means then the motion is said to be here uniform circular motion. Right, in which angular displacement means the angle subtended by the object when it is moved from one point to another point on the circular path is called here angular displacement. Angular displacement can be measured in terms of radians. Right, angular velocity means the rate of change of angular displacement is called here angular velocity. Angular velocity equal to angular displacement by time. Actually, for a complete revolution, okay, one complete revolution means angle 360 degree. Okay, pi is nothing but 180. 2 into 180, 360. Right. Omega equal to 2 pi by t. 1 by t is nothing but here. What is their frequency like that also? Angular acceleration means the rate of change of angular velocity is called here angular acceleration, which is denoted by omega. Alpha equal to omega by t. That is nothing but unit for this one is nothing but radian per second square. Time period means the total time taken by the object to complete one revolution is called here time period, which is denoted by capital T. Frequency means the number of rotations are made by the object in a second is called here frequency. Number of rotations, number of revolutions, number of oscillations, number of movements is called here frequency. Relation between linear velocity and angular velocity. So we know that from the definition of angular displacement, theta is equal to, we can write s by r. So from this one, differentiate with respect to 2t on both sides. We may get here omega into kilometers. V is equal to r omega. This is nothing but linear velocity, angular velocity relation. A is equal to r omega. This is nothing but relation between acceleration and angular acceleration. Their vector forms also s negative. Yeah. Next, there is one very important question is there. There are the expression for centripetal acceleration. Centripetal acceleration means, okay, the acceleration by the object when it is in uniform circular motion. That means the acceleration experienced by the object when it is in uniform circular motion is called here centripetal acceleration. Now there are two things are there here. One is nothing but we have to derive the expression for centripetal acceleration, that is the first aim. Second aim is nothing but we have to prove the direction of the acceleration, centripetal acceleration. Now to do this one, here I have taken one circular path. Now this is the center of the circular path. Now from this center of the circular path, see here there is an object. Now here there is one object is there. Okay, this object, the position vector is nothing but what I can write, that is nothing but r bar. R bar is nothing but the position or radius vector of the object in a circular path. Right, at this point the direction of the velocity is nothing but, okay, along the tangent that here I am representing, that is v bar, velocity of the object. And thereafter, after some time, the object is moved from point P to some another point, that is nothing but P dash. It has reached from P to P dash. To move the object from P to P dash, how much time it has taken means, it has taken some time. That time is nothing but here delta t seconds. Right? In delta t seconds, after delta t seconds, object has reached from P to P dash. Okay, which is nothing but like this. Now here, this one is nothing but here. Okay, position vector r bar dash of the object at a point P dash. Now this is the position of the object initially. Now this is the position of the object finally. Here the velocity of the object is nothing but v bar. Here the velocity of the object is nothing but what I can write, v dash bar. I can write. Okay, I can write v dash. Now this is nothing but position vector r bar when the object is at a point P. Here r bar dash is the position vector of the object at a point P dash. Is it? Right. When the object is moved from P to P dash, here at the center, it subtended some angle. That angle is nothing but here delta theta. Delta theta is nothing but angle subtended. This delta theta is nothing but here angular displacement in this situation. And thereafter, sir, what is the displacement of the object here? Now object has displaced from where to where? P to P dash, like this, P to P dash. So displacement is nothing but what I can take here, that is nothing but delta r bar is the displacement. Now this is the center of the circular part. We can take it as like this. Okay, fine. Right. Now here this is the displacement of the particle. Initially particle is being here, after some time it has reached to this point. Is it? Right. Suppose this V is there. For this P, parallelly here I am drawing a vector here. That is nothing but from this P, okay, I am drawing a vector like this. Now this is nothing but V bar I have taken. So this is nothing but G and this is nothing but H. And thereafter, for this one only, similarly one parallel vector I am drawing here. Okay, that is nothing but how I can draw it like this. That is V bar dash. See here, for this one I have drawn a parallel vector V bar. For this one I have drawn a parallel vector V bar dash. That means initially velocity is v. After some time, velocity has changed from v to v dash. So velocity is changed from where to where? V to v dash. So change in velocity is how we can show? We can show it like this. That is change in velocity delta v. Change in velocity. Change in position delta r. Change in angular position delta theta. Change in velocity is nothing but delta v. Here you take it as that is nothing but I. Now this is the direction of change in velocity. Sir, uniform circular motion. Is it a uniform? Is it an uniform motion or non-uniform motion? Uniform circular motion is an accelerated motion. That means uniform circular motion is accelerated motion means here object is having the acceleration. What is the direction of acceleration means? Direction of acceleration is along the center of the circular, along the change in velocity direction. What is the change in velocity direction? Change in velocity direction is being like this. So in this direction only what will be there? Centripetal acceleration will be there. So what is the direction of centripetal acceleration? Direction of centripetal acceleration is along the radius of the circular path and towards the center. Towards. See, direction I am showing towards the center. Is it? Yes. Now simply, instantaneously suppose we just to see how to write. Okay. Acceleration of an object in uniform circular motion is AC equal to centripetal acceleration is equal to limit delta t tends to 0 of delta v by delta t, delta v by delta t. Now this is the acceleration definition, centripetal acceleration. Now thereafter, if you come to the diagram, in this diagram, okay, R bar is perpendicular to V bar. From figure, we can write R bar is perpendicular to V bar. Is it? See, this is the R bar and this is the V bar. Next, thereafter, R bar dash is perpendicular to V bar dash. R bar dash is perpendicular to V bar dash, and therefore delta R bar is also perpendicular to delta V. Delta R bar is also perpendicular to delta V bar. Okay, fine. Here angle is delta beta means here also angle what we can take means angle is nothing but delta theta itself. Delta theta itself. Now whether you are observing or what, from the figure, okay, from the diagram, triangle CPP dash, see, triangle CPP dash and GHI are similar. Triangles, okay, CPP dash and GHI, both are what type of triangles? Means both are similar triangles. If both are similar triangles, if there are two similar triangles are there, then we can equate the ratio means both sides divided by ratio of, okay, their sides. Which sides? Delta V bar one side by V bar and delta R bar by R bar. So delta V bar by V bar, sorry, delta R bar by R bar and delta V bar by V bar. Is it? Now from this one, delta V is equal to what we can write? See, delta V1, delta V is equal to, we can write V into, this V will come this side means V by R into delta R, we can write, that is equation number 2. Next, from the definition, from the equation 1, centripetal acceleration AC equal to, we can write limit delta t tends to 0 of what we can write now? Delta V is there. Delta V means what we can write instead of delta V? V by R into delta R whole divided by delta t, we can write. Now from this one, centripetal acceleration is equal to limit delta t tends to 0 of V by R, okay, take it outside, and delta R by delta t, we can write. Now from this one, AC is equal to V by R into limit delta t tends to 0 of what we can write? Delta R by delta t, we can write. Now from this one, AC equal to V by R into when the limit delta t tends to 0 of delta R by delta t is nothing but change in position divided by time is called here velocity. So velocity V we can write. So that is AC equal, we can write V square by R, we can write. Now this one is nothing but here centripetal acceleration. Right? Now we know that V is equal to R omega. Previously we have defined relation between linear velocity and angular velocity. Now this one, centripetal acceleration is equal to R square omega square divided by R. If R cancel means centripetal acceleration is equal to R omega square we can write. Now centripetal acceleration in terms of linear velocity, in terms of angular velocity. Next, you just see omega is equal to what we can write means 2 pi f omega equal to since 2 pi f same the centripetal acceleration r into omega square is nothing but 2 pi f whole square. If you write means AC is equal to 2 into 2 square is nothing but 4 into pi square into f square into r you can write. Now this is nothing but here centripetal acceleration, right? Now this is the centripetal acceleration. Centripetal acceleration we can write in different forms here, right? In terms of frequency I have written, in terms of acceleration linear velocity I have written, in terms of angular velocity also I have written. That means what is the direction of centripetal acceleration at the center point means, now you just see this is the center point and this one is nothing but radius vector. Here the velocity is nothing but along the tangent to this circular path we can write v. Then the direction of centripetal acceleration at any instant of time is nothing but like this. So centripetal acceleration is along the radius and towards the center of the circular path. Here I am writing, just see the direction of this step, you write very last one, finally you write the direction of centripetal acceleration is along the radius and towards the center of the circular path. Towards the radius and the center of the circular path. Okay, this is very along the radius and towards the center of the circular path, which is the centripetal acceleration. Very, very important. Now this is the expression for centripetal acceleration. Okay, in exam point of view, you write till here it is enough. Okay, these two are very important in problems. Okay, you write, you learn completely. I have given in notebook. Yes, next.